There is a tunnel, and machinery inside that tunnel sends beams of energy in a vast circle.
And how the particle accelerator altered the weight of one electron and therefore destroyed our universe and shifted us into the universe that's directly next to it, and therefore things are different in this universe.
Max Laughlin, often hailed as the brightest child on the planet, has voiced alarming theories about CERN's potential. He warns of the purported misuse of CERN's technology by scientists seeking to open a portal to another dimension. In an era where our scientific strides have reached alarming heights, the Large Hadron Collider, LHC, made by CERN, stands not just as a beacon of human achievement, but also as a potential Pandora's box. While it's undeniably the most formidable particle accelerator ever built, the LHC has ignited a whirlwind of debates that touch upon the very nature of reality, the possibility of parallel universes, and the puzzling Mandela effect. Beyond the awe-inspiring discoveries like the Higgs boson, we have Max Laughlin's stark warnings and theories that suggest we might be living in an altered reality. What exactly does this mean? Let's find out. Max Laughlin's alarming theory: CERN's experiments and the quest for parallel universes. Max Laughlin isn't your average kid. By age 13, he had already grabbed the world's attention with an invention that promised free energy for all. A bright spark in the scientific community, his theories aren't just food for thought, they're also a warning sign. Now, he's back in the spotlight with a bold, unsettling prediction about the Large Hadron Collider at CERN. According to Max, researchers may have opened a door to an entirely unknown portal, and while his ideas may sound like science fiction to some, there's no denying the serious waves they're making worldwide. In various videos, Max explains his beliefs without getting lost in scientific jargon. He points towards the uncertain possibilities that lie in the paths of CERN researchers. Whether or not the scientific community agrees, Max's youthful perspective and unexpected insights definitely make people stop and think, what if he's right? His previous invention, a free energy machine, already turned heads and left people wondering just how much potential is locked inside this young mind. It wasn't just an invention. It was a message about a future Max believes is fully within our grasp. Now, with his new warnings about the potential dark side of scientific exploration, Max challenges us all to consider the unknown and unexpected consequences of our pursuits.
And we are living in an alternate expansion of our universes. Even in my own scientific notes, I've found rewritten signatures and things that are a little bit different from originally what I wrote.
Max Laughlin made waves when he presented yet another groundbreaking idea. Besides his talk on free energy, he dove deep into some hypotheses that are based on detailed observations of our universe and possibly a parallel one. Max's alarming theory suggests that CERN's experiments, especially those involving the Large Hadron Collider, could be more than just scientific exploration. He worries they might disrupt our reality, potentially pushing us into an alternate dimension much like ours. Now, what Max is suggesting raises big questions about our role in the universe. Space has always been a mystery. It's big, complex, and full of stuff we're still trying to understand. CERN is at the forefront of trying to figure it all out. They're known for their work on the Large Hadron Collider, LHC, a massive machine that recreates conditions similar to those just after the Big Bang. By smashing tiny particles together at incredible speeds, the LHC helps scientists get a closer look at the building blocks of everything. But with Max's theories in mind, we're left wondering, are we pushing the boundaries of understanding, or are we risking too much? Max Laughlin offers a riveting interpretation of the results of these experiments. He postulates that the LHC may have unknowingly disrupted our universe's fabric. Such a rupture, he argues, might have thrust humanity into a parallel reality. The concept is breathtaking. The existence of an infinite multiverse, where every possible scenario plays out in endless parallel universes. According to Max, we might not inhabit the original universe we once did. The moment the LHC's experiment encountered an anomaly, humanity was catapulted into an alternate reality. As if we're flipping through pages in a vast cosmic book, every moment might see us shift into another parallel universe. This concept isn't just a mere jargon. It speaks to a broader understanding of quantum mechanics and the many worlds interpretation. Each decision, each quantum event, births a new universe. Every second we could be transitioning between these universes, mostly unaware of the shifts. Intriguingly, Max has put forth a fascinating idea. He thinks that scientists at CERN might actually know about a disturbance in the space-time continuum. After noticing this irregularity, they might have even manipulated events, suggesting that our reality might not be as stable as we thought. This theory aligns with rumors that CERN is actively working on creating portals, seeking ways to connect different parts of the universe. The Mandela effect, a phenomenon where a large number of people remember something in a way that contradicts current historical records, further lends weight to Max's argument. He proposes that such collective false memory might be traces of our original universe, echoes from a reality we left behind due to the particle accelerator's experiments. This theory suggests that even a minor alteration, such as the change in one electron, could have significant implications, enough to shift us to an entirely different reality. The Large Hadron Collider, LHC, located under the border between Switzerland and France, is an impressive piece of engineering. It's not just a big experiment, it's a huge leap forward in trying to satisfy our curiosity about the universe. The LHC smashes two particle beams together and lets scientists see the atomic and molecular reactions that happen as a result. Through these experiments, scientists hope to understand more about the basic makeup of the universe and maybe even discover its hidden secrets. However, the LHC hasn't always been viewed with enthusiasm and wonder. From its early days during Bill Clinton's presidency, it faced skepticism. Some experts, driven by fear and doubt, thought the LHC might accidentally create a black hole, posing a real threat to Earth. While the notions surrounding CERN and the LHC oscillate between awe and apprehension, one thing is evident. We stand at the precipice of understanding. As we look deeper into the universe's secrets, we must tread carefully, ensuring our quest for knowledge doesn't indirectly reshape the very essence of our reality. Quantum physics can be complicated and sometimes leads to big questions about our existence. One such debate was sparked by Francesco Calogero, a notable nuclear physicist from the University of Rome and co-winner of the 1995 Nobel Peace Prize. In 2000, he wrote an article titled, "Might a Laboratory Experiment Destroy Planet Earth?" As you can imagine, this caught people's attention and started many discussions. The main question everyone asked was, could the Large Hadron Collider, LHC, an impressive piece of engineering, be dangerous for our planet?
As cheesy as this sounds, from day one on this planet, I knew that I was put on here for a reason, and that reason is to invent, to bring the future.
Calogero's article quickly caught the public's eye and became even more popular when it was discussed on John Oliver's Daily Show in 2009. In that episode, Oliver shared an interview where a physics professor said there was a 50% chance the LHC might create a black hole, which could be disastrous for Earth. To ensure viewers got both sides of the story, Oliver spoke with experts at CERN, the organization behind the LHC. They were clear in their message: the LHC wasn't built to harm the planet. It was designed to push the boundaries of scientific discovery. However, the mystery deepens when the conversation shifts to the Mandela effect. Max Laughlin, whose theories on parallel universes are both fascinating and confounding, expressed his belief in the phenomenon. The Mandela effect is a curious instance where a large group of individuals recall a particular event that, in reality, never occurred. This mysterious collective false memory appears to back up the little geniuses theory, the Mandela effect, collective memory, or alternate reality. The term Mandela effect was formulated in 2009 by Fiona Broome. Its origin is as captivating as the phenomenon itself. Broome distinctly remembered Nelson Mandela's death occurring in the 1980s, with television coverage, including a moving speech by his widow. But here lies the paradox. Nelson Mandela did not pass away in the 1980s while in prison. He died in 2013. At a conference, Broome's recounting of her memories led to a revelation. Many attendees shared the same vivid and specific recollections of Mandela's supposed 1980s death. This was not just a simple misremembering by one person, it was a collective and consistent false memory by several individuals. Broome, shocked by the experience, created a website to dive deeper into this phenomenon, seeking others with similar memories and trying to unravel this enigma. The Mandela effect transcends just the story of Mandela. Numerous such instances can be found where significant numbers of people remember details, events, or timelines that starkly contradict documented history. From misquoted movie lines to misremembered historical events, these discrepancies pose questions that challenge our understanding of collective memory. Relating this to Max Laughlin's idea, it makes you think, could these mixed-up memories be traces of a past timeline? Maybe they're hints from a universe we used to be in before moving to a different one. While it's just a theory, it's an interesting way to think about the Mandela effect. Maybe these aren't just forgetful moments, but signals from another universe. While the Large Hadron Collider's true capabilities and its potential impact on our reality continue to be subjects of debate and speculation, it undeniably stands at the intersection of profound scientific exploration and existential wonder. The Large Hadron Collider, LHC, is a big deal in the world of science. It was built by scientists to test theories about particle physics, mostly dealing with the Standard Model. While this model can explain a lot, there are still some anomalies and mysterious occurrences it can't quite account for. Constructed in 2008, the LHC has seen two major runs, the first from 2010 to 2013, and the subsequent from 2015 to 2018. Both runs not only established records but also resulted in groundbreaking discoveries. Among its achievements is the detection of the Higgs boson, a particle whose very existence underpins our understanding of mass. The Higgs boson, often dubbed the God particle, is a fundamental particle discovered in 2012 by the Large Hadron Collider at CERN. Its existence confirms the Higgs field theory, which postulates that particles acquire mass by interacting with this field. Proposed by physicist Peter Higgs in 1964, this boson's discovery was a significant breakthrough, filling a critical gap in the Standard Model of particle physics. Finding the Higgs boson filled a major gap in the Standard Model of particle physics, and it continues to be crucial in our understanding of how the universe works. However, the shadow of dark matter looms large. A substantial part of the cosmos, dark matter remains hidden from human sight. Yet, its gravitational influences have been sensed, leading scientists to firmly believe in its existence. Functioning as a cosmic adhesive, dark matter binds galaxy clusters and individual galaxies, but its exact nature remains ambiguous, presenting one of science's greatest puzzles. Dark matter, the unseen hand of the cosmos. Dark matter is one of the most puzzling aspects of astrophysics. While it doesn't interact with light, meaning it doesn't emit, absorb, or reflect it, we can still sense its massive influence throughout the universe. Estimates suggest that it makes up about 27% of the universe's total mass and energy. The primary proof for dark matter comes from the gravitational effects it seems to have. It's crucial in keeping galaxies, and even larger structures, like clusters of galaxies, intact. Without dark matter's pull, the stars in galaxies would be moving so quickly they'd be thrown out into space. We've gathered evidence from how galaxies rotate, background radiation left over from the Big Bang, and ways gravity bends light from distant objects. But the big unanswered question is, what exactly is dark matter made of? While everything we see around us, from stars to planets to people, is made of atoms, dark matter seems different. It's believed to be made up of yet-to-be-discovered particles. Discovering these particles is a top priority in physics today, and researchers are conducting experiments everywhere from deep underground to space, hoping to uncover this cosmic secret. The inception of the LHC was fueled by an aspiration to answer such enigmatic questions. Initial optimism during its 2010 startup was noticeable, with physicists anticipating revolutionary revelations. While the Higgs boson discovery was a monumental milestone, the much-anticipated insights into dark matter's composition remained undiscovered. After its 2018 run, the LHC went through an extensive phase of maintenance and upgrades. When it powered up again on April 22, 2022, it marked a significant moment, coinciding just a day after the Higgs boson's 10th discovery anniversary. However, the real highlight of 2022 came in January when CERN scientists made a groundbreaking revelation: the detection of X particles. Named due to their mysterious nature, these X particles were identified within the dense sea of the LHC's quark-gluon plasma. Evidence suggests that these particles have roots tracing back to the universe's initial moments, a time a few millionths of a second after the Big Bang. During these primal moments, an intensely hot, trillion-degree mixture of quark and gluon plasma filled the cosmos. As the universe expanded and cooled, these elementary particles began forming the protons and neutrons we recognize today. But before this transition fully materialized, a small portion of them merged, giving birth to the short-lived X particle. X particles, unraveling the universe's ancient mysteries. Within the high-speed particle chaos inside the Large Hadron Collider, LHC, a new discovery has piqued scientific curiosity: the X particles. These mysterious particles offer a window into the universe's early moments, providing potential insights into the fundamental building blocks of existence. The X in X particles isn't just for theatrical effect. It represents the mystery enveloping their very essence. Amid the sprawling ocean of particles in the LHC's quark-gluon plasma, these unique entities made a mark, not by their prevalence, but by their origins. It's captivating that these particles provide a link to a time just after the Big Bang, when the universe was a chaotic hotbed of elementary particles, quarks and gluons. As the fiery, budding universe expanded and cooled, quarks and gluons began to stick together, eventually forming protons and neutrons, which make up the matter we encounter every day. But the X particles tell a different tale. They give evidence of a puzzling moment when some quarks and gluons combined, not to create protons or neutrons, but to form something entirely different, albeit briefly: the X particle. Recreating the conditions of the universe's genesis is no small feat. Yet the team at CERN managed to simulate this environment by accelerating positively charged lead atoms to immense speeds and crashing them into one another. This experiment, mirroring nature's own particle accelerator during the Big Bang, created a fleeting burst of plasma. This plasma was similar to the environment in the universe's earliest moments, leading to the birth and death of countless particles. Within this dynamic environment, discovering the X particles was like spotting a needle in a cosmic haystack, showcasing the analytical prowess of the researchers involved. But why does the discovery of the X particle matter? Their presence, however transient, offers a rare window into the primordial universe, a time capsule of sorts. By understanding how they form, and more importantly, how they're structured, we can deduce the interactions and properties of particles in the universe's nascent moments. This knowledge is invaluable, not just for pure scientific understanding, but also for understanding the cosmic choreography that led to the formation of galaxies, stars, planets, and ultimately, life itself. Yet despite this groundbreaking discovery, the X particles remain a cryptic puzzle. The precise manner in which the elementary quarks and gluons come together to form this structure is still a topic of ongoing research. It's like having a piece of an ancient manuscript but not knowing the language it's written in. The more we can decipher about the X particles' formation, the closer we get to translating this cosmic language. The LHC, with its operational period extended till 2025, might be humanity's best shot at answering some of these perplexing questions. CERN's scientists' ideal endgame would be the LHC unraveling the cryptic nature of dark matter. Given that it constitutes most of the universe, understanding dark matter is not just about satisfying scientific curiosity. It's pivotal for predicting the universe's expansion. The journey of understanding our cosmos has taken us from the mind-bending concept of dark matter to the revelation of elusive X particles. Yet, like a never-ending spiral, the more we learn, the more questions arise. These inquiries not only shape the scientific community but also challenge our very perceptions of reality. Such discussions spark passion, as seen in the lively debates, concerns, and speculations voiced by many of you. Are we in an alternate dimension? Are our memories and realities reliable? As we continue exploring these questions and the groundbreaking findings of CERN, let us remind ourselves of the boundless potential that lies in collaborative scientific endeavors. Thank you for being with us. Make sure to watch the next video on your screen. It's amazing!